Hello and welcome to a video on complex zeros of a polynomial function. And we're going to look at two different kinds of examples in this video. And the first kind of example is we're going to use a given complex zero to find remaining zeros of a polynomial function. So that's like example one. Example two is going to be find complex zeros of polynomial functions that require factoring, and that's the one down here, example two. Well, let's focus on first thing first. So we are looking for the remaining zeros, right? We're finding all the remaining zeros. And to do that, we're going to keep in mind that connection between the zeros and the factors. In other words, if this is a zero, in fact, we know that there's three zeros here. We know that there's three roots because this is a third degree function. So we know that this third degree function has to be somehow possible to write this as three factors because it's third degree. And each factor is subtracting the root from x. So each factor is going to come in this form. And we're given one of the factors. So let's put our factors in blue. We're given the 4 plus 3i. So we know, let's put the zeros in blue. So we know we're going to subtract 4 plus 3i. And if 4 plus 3i is a 0, then so is 4 minus 3i. So we know we're also going to subtract 4 minus 3i. And those are the easy factors because, well, one of them was given and the other one doesn't require any work to find. The hard one is to find what's the factor over here. So this is the hard one. And that's what we're going to do. The rest of our work will be just really to find that. Now, if we know that the product of all of these is equal to this trinomial, then we should be able to divide this stuff right here, whatever that ends up being, into the third degree polynomial, and we should get the remaining factor. And that's our strategy. So we're going to figure out what this is by multiplying it all together, and whatever we get, and it will be a real number, it'll end up being a trinomial, we'll see in a minute. A second degree trinomial, and we're going to divide it into this third degree because the third degree isn't factorable and there's really no other approach here. So we're going to multiply out x. Now let's do this in black ink. So we're going to multiply out x minus 4 minus 3i. That's just distributing the negative sign in this term, times x minus 4 plus 3i. And that's just distributing the negative in this term. All right, and we're going to do that making a grid. This is the way we've been doing it in the past, so we're just going to continue with something that works pretty well. And it's the least likely way to make a mistake. So we have x minus 4 minus 3i, x minus 4 plus 3i, and we just fill in the grid. So x times x times negative 4, x times negative 3i, and then the second row, negative 4 times x, negative 4 times negative 4 is 16, negative 4 times negative 3i is 12i, 3i times x is 3xi, 3i times negative 4 is negative 12i, and 3i times negative 3i is negative 9i squared. And since we know that I squared is negative 1, we can think of this as negative 9 times negative 1, which is really just 9. Okay? Now we can look at these diagonals. 1, 2, 3, 4, 5 diagonals there. So let's see what we get. First of all, the easiest one to look at here is the one that cancels. These just cancel away. 12i minus 12i is 0. The other thing that cancels is this term cancels with this term. So what's left? We have x squared, and then we have minus 8x, and then we have that 16 and 9, and that's 25, so plus 25. So this whole thing is really just equal to this trinomial. So that means we can now divide this trinomial into this third degree 4-term polynomial, and whatever we get for the quotient will be our other factor. So let's go ahead and do that. Long division, can't use any synthetic division with this. x to the third minus 3x squared minus 15x plus 125. Now let's just kind of backtrack here what we're doing. We know we're given that this is a 0. We know that this is also a 0. Therefore, we know that all of these together make a factor. We multiplied them together and we got a factor. So we expect that this whole thing should go evenly into the trinomial. In other words, we are expecting and hoping for a remainder of 0. If you get a remainder of anything else, you got to go back and look for your mistake. Because if you're given one of the zeros, either you're lied to or you made a mistake somewhere along the way. All right, so let's hope we didn't, and let's hope that when we divide, we get a remainder of 0. So we have x squared times what equals x cubed, and that's just x. And then we're going to distribute the x over all three terms, and we get x cubed minus 8x squared plus 25x. All right, then we're going to subtract, carefully subtract. We get a 0 there. I'm going to write down, just a reminder, negative 3x squared minus negative 8x squared. That's 5x squared. I'm going to get that 0 out of the way. It's just kind of confusing. Subtract here, negative 15 minus 25. So negative 15x minus 25x, that's negative 40x. And then carry down the 125 and do the next round. So now we ask, what does x squared multiply to give us 5x squared? And that's just 5. And then we distribute and hope for a remainder of 0. So we have 5x squared minus 5 times negative 8 is minus 40x. So far, so good. 5 times 25 is plus 125. It's looking like we have the same trinomial there, so the remainder is 0. This is our factor. That 5 is what goes right there. Okay, so now we can answer the question. Use the given 0 to find the remaining zeros. The given 0 was 4 plus 3i. The remaining zeros, four minus 3i, and this is plus 5 here. And so we're subtracting a negative 5, so the other 0 would be negative 5. Okay, let's look at the next example here. Find the complex zeros of a polynomial function. So this is just one that we have to factor. And then we're going to write the function in factored form. And once we find all the complex zeros, now we're going to think of factored form as going beyond factoring, but in fact finding all 6 factors. Now there may be some repeated factors. In other words, there may be some exponents that are higher than 1, but there's going to be 6 factors. In other words, ultimately, I know I'm going to get 1, 2, 3, 4, 5. Did I count right? 6 factors. Now again, and they're all going to be x minus something. And there might be some imaginary numbers in there. There might be some irrational numbers in there. And there might even be duplicates, which would be repeated factors, which would give you an exponent of 2. But there are that many factors. Okay, so let's go searching for those factors. And it's going to start out with the process of factoring. And this particular problem, you can look at it as either a difference of squares or a difference of cubes. And depending on which way you look at it, your path will be different, but you should end up in the same place. So let's start out with the difference of squares. All right, so let's look at this as x squared. Oh, I said a difference of squares, didn't I? So let's look at this as x cubed squared minus 8 squared. Difference of squares, just factors to give us plus and minus. So we have x cubed plus 8 times x cubed minus 8. Okay, so far so good. Now we have we have a sum of cubes and a difference of cubes. So remember, with the sum of cubes, you start out with the binomial times a trinomial. By the way, don't forget this is a sum of cubes. This is x cubed and this is 2 cubed. So it is a sum of cubes. All right, so we start out with our binomial. We put the x and the 2 at the beginning and the end. We put the squares at the beginning and end of our trinomial, so we have x squared and 2 squared, which is 4. And then we put the product in the middle, so that's a 2x. And then we apply SOAP, same, it's plus, so the same is plus, opposite, always positive. And then we do the same thing with the x cubed minus 8, binomial, trinomial, the pieces are all the same, the signs are different. And this one is minus, so this one would be same, opposite, always positive. All right, so I think we can safely say we've got 2 of these done. We now know the 2, and we know the negative 2. Okay, so we've got a couple of these done. I could have just written, just to be a little bit maybe clearer at the first step. It's still going to be plus, but we can write it as negative 2. Okay, we've got those first 2. Now we're going to get 4 more. So we're going to get 2 more from here and 2 more from here. And we've talked about this in the past, but when we are looking at the trinomials formed from a sum or difference of cubes, they're always going to be non-real. So we know we're going to have to use quadratic formula for these. So we have x equals negative b plus or minus the square root of b squared, that's 4, minus 4ac. Oops, c is just another 4. I'm multiplying it ahead of myself. All over 2a. All right, so we can, and then let's just simplify this one first. So we have 2 plus or minus the square root of 4 minus 16. That's negative 12 over 2. Okay, that the negative is an I, and the 12 is 4 times 3. So this is 2I rad 3. So this is 2 plus or minus I times 2 rad 3. All over 2. The 2's cancel, and this is 1 plus or minus rad 3. Oh, I rad 3. All right, we've just found 2 more of our roots, so let's put them in there. We're more than halfway done now. So we have, here is 1 minus I rad 3. And then 1 plus I rad 3. And then we have to do one more quadratic formula and we'll be done. So why don't you go do this, and I'm going to pause the video and see if we match. Okay, so it's almost the same, negative 1 plus or minus I rad 3. So we can put those in there and we're pretty much done, just a little simplifying. Negative 1 plus I rad 3 and negative 1 minus I rad 3. Let's simplify, make sure they're all different, and then we'll write the zeros down. So we have f of x equals x minus 2 times x plus 2 times x minus 1 plus I rad 3. Well, we can just write it. Let's see, are these all different? Let's expand it out. It really doesn't matter as long as I see this part. I'm good with knowing how to do it, but I still want to see if they're all different. So we have x minus 1 plus I rad 3. That's the first one. Then we have x minus 1 minus I rad 3. Then we have x minus x plus 1, right? X plus 1 once we distribute that negative, minus I rad 3. And then this one is x plus 1 plus I rad 3. And now if we look at these, none of them are the same. They look like they're really close to being the same, and that's why I want to distribute to make sure it's clear that x minus, these first 2 start out with an x minus 1, the next 2 start out with an x plus 1, and they're in fact all different. This is factored form. You could have written this as factored form, just leaving these blues like they are. Now the zeros are x equals plus or minus 2, and we already found them down here, so there's 2 of them, 1 plus or minus I rad 3, and negative 1 plus or minus I rad 3, and that's it. I hope you found this helpful.